You are once again welcome to our online lesson, Math Made Easy with PDY, in connection with e-learning Ghana. Now, in today's lesson, we are actually going to look at what we call terminating and non-terminating decimals into details. And by the end of the lesson, you should be able to write terminating decimals as a rational number and then non-terminating but recurring decimals as rational numbers. That's what we are going to consider today. So just a quick one. We found out that terminating decimals are decimals which do end. Terminating. They are decimals which has an end. So just that. So example of terminating decimals, we can say we have 0.1, we may have 0.25, we may have 1.36, etc. So these are all examples of terminating decimal. They have an end. It just ends. And then we have non-terminating. So for that one, does not end. So does not end. So you may have 0.12456 dot. So this means it's not ending. It goes all the way to infinity. It goes all the way to infinity. So having these three dots at the end tells you that it's a non-terminating decimal. It's a non-terminating decimal. But what we'll be looking at is non-terminating but recurring. So non-terminating but recurring. So it does not end, but it does what? There's a number pattern that goes all the way to infinity, for which you can keep on writing until like you are tired. So for instance, you may have 0.11111 all the way to infinity, which we can cut it short as 0.1 with a dot on top. The dot which is on top is showing that the 1 is recurring. So I may have 1.22222 all the way to infinity, which we can actually say that this is approximate to 1.2. Since the 2 is the digit which is recurring, then we put a dot on the 2. So the first two examples are non-terminating decimals, but they are recurring. Please, is it clear?
Yes, please.
So there are circumstances whereby you may have only one digit recurring. You may have more than one digit recurring. So you may also have 7.343434 all the way to infinity. So we can say that this is the same as 7.34. The 3 and 4 are recurring. So you put two dots on top of each digit which is recurring. Then I may also have three digits recurring, which is let's say 0.123123123 to infinity, whereby we can write this as 0.1, 2, and 3 with 3 dots on top of each number which is repeating. Or you can write it as 0.1, 2, and 3. Then on the 1 and then the 3, you put a dot on top. Now, when you write it in this form, it still means that the 1, 2, and 3, they are all recurring. So either you write it in this form or that form, it still means the same thing. Please, are we all clear? Are we all clear,
Yes, please.
please? So our major concern now is to convert these decimal numerals to rational function or to a fraction form. That's what our major concern is today. So without wasting much time, let us start with how to convert terminating decimals to fractions. So how to convert terminating decimals So this is what we're going to do right now. Then after which, the section whereby it's going to take much of our time is when you are looking at recurring decimals to fractions. So let us box on. So I've given you some examples. So having, let's say 0.1, changing it to a fraction, it's very easy. It goes with a pattern. If you know your place value very well, it becomes very easy when you are changing them to fraction form. So let us do a little review on place value. Remember, we are dealing in base 10 or decimal. So we are dealing in base 10. Hence, if I have a number given as 124.56, the place value of the 4, so we are looking at just place value so that to make it easier for you to understand how we are going to work things out. Place value of the 4 is what? What's the place value of the 4? Of the digit 4?
Please 10.
Oh, look at it carefully. The 4. Look at where the position of the 4 is.
One.
It's supposed to be ones. Very good. Then we come to the digit 2. That would rather be the tens. Then we come to the first digit, which is actually going to be what? Hundreds.
100.
Good. Then after the decimal point, the first digit is what? What's the place value? The name of the place value? Tenths. Tenths, yes. Meaning it's a fraction. Then the 6 will be hundreds. Hundreds. THS. So it means it goes back to the old place value, but this time you add THS to it. That's all. So since you are dealing with base 10, then when you are writing any decimal, terminating decimal into a fraction form, then you have to consider the place value of that decimal. So for instance, we have 0.1. Now, the numeral or the first digit, which is we need to consider, is 1. And the place value of the 1 is tenths. So it means if I want to write this in a fraction form, then it's going to be that digit divided by its place value. And the place value is 10. So we are going to have 10. Just that. So it becomes 1 on 10. My people, are you following me?
Yes, please.
So if I have 0.12, 0.12, then it means I have to consider the whole numeral 12. So the place value of the last digit is what we need to consider. What's the place value of the last digit, which is the 2? What will be the place value of the last digit?
10.
100.
That is hundreds. So in other words, if I want to write this in a fraction form, then I consider the whole numeral there, 1, 2, to be 12, divided by the place value of the last digit, which is going to be 100. Please, does it also make sense?
Yes, please.
Good. Another example, I may have 1.436. 1.436, then we have to consider the place value of the last digit. Now, what is the place value of the last digit, which is the 6 over there?
Thousands.
Thousands. Good. So it means that I just have to convert all the digits there to be 1436 divided by 1000, and that is all. Which we can go further and write this expression in what we call the mixed number form. And the mixed number will be how many thousands are we having there? It is 1. Then 436 out of what? 1000. So this is the mixed number for this fraction. Please, that doesn't make sense.
Yes, please.
So the simple and short of it is that whenever you are changing any terminating decimal to fraction, you must consider the place value of the last digit of that decimal. So can you try this for me? I have 12.78. How can we change this to a fraction?
Sir,
Yes, go ahead.
1278 out of 100.
So 1278 out of 100, which is the same as mixed number.
One whole number. 278 over 100.
Are you sure of what you say?
No, please, I'm coming.
No, to 12 whole number
It's 12 whole number,
78
78 over 100. At first, I thought I heard something like one whole number, 278 over 100. I guess that's what I heard, right? That's why I was asking, are you sure of your answer? Okay, so it's easy to convert decimals to fractions when they are terminating decimals. Please, can we move on to the next?
Yes, please.
All right. Unless you have a question, then I will have to respond to that. Now, again, we are moving on to this time around non-terminating, but recurring decimals to fractions. Please, I'll bear with you to be very attentive to what I'm going to do right now. This is the aspect students find it a bit difficult understanding. When it comes to the first part, it's easy, but this aspect, it becomes a bit challenge for students to understand. So I'll beg of you to be attentive. Don't let anything distract you and follow whatever I'm going to teach right now. All right, so I gave you some other examples on non-terminating but recurring decimals, for which I said that we may have 0.1 with a dot on top, and the dot means the one is recurring. We may also have 1.2 with a dot on top of the 2, meaning that the 2 is recurring. We may have 3.78 with a dot on top of only the 8, which means the 8 is recurring, but the 7 is not recurring. The 3 is also not recurring. Now, one thing you should understand is that the whole number section cannot recur, but after the decimal point, any of the digits after the decimal point may recur. That's why we are saying non-terminating but recurring decimal. So meaning after the decimal point, that is when you have the recurring occurring. So I believe someone would have asked, why is it that the whole numbers are not recurring? You can't have the whole number section recurring. It's only after the decimal point that you may see it recurring. That's why we are talking about recurring decimals and how to write them in a fraction form. We are going to take this aspect in 3 different categories. And what are the 3 different categories? We are going to consider when only one digit after the decimal point is recurring. Then we'll move on to when 2 digits are after the decimal point are recurring. Then finally, we'll look at when 3 digits after the decimal point are recurring. Even we have the section whereby some numbers are not recurring after the decimal point and others are recurring. So please, I want you to pay attention to the procedure by which we go through to convert recurring decimals to fractions. Are we ready for that?
Yes, please.
Good. at this point, I'm giving you the question, but at another section, I'll be asking you to generate some questions. Then we do it together. Yes, I don't want the situation whereby I'll give questions, then you may think that I'm giving easy questions. But I would like you to also give some other questions, which are possible questions. If it's not a possible question, I'll let you know. If it is, yes, I'll let you know. Then we'll do it together. So just be thinking about some of them. So let's begin with this one. So considering how to convert a recurring decimal to fraction, first, we've said that if you have any recurring decimal, it means that number after the decimal point is written all the way to infinity. So watch something here. The 0.1 recurring that I have ideally is the same as 0.1111111 all the way to infinity. Does it make sense?
Yes, please.
So please watch this carefully. You don't know the end of the number because it goes all the way to infinity. So this is the procedure by which you follow whenever you are converting a recurring decimal to fraction. First, you need to generate an equation. You generate an equation. So you can say that let a variable, so let's say the variable x should be equal to the recurring decimal. So 0.1 recurring. That's the first step. Then the next step is you have to transpose one of the recurring decimals to join the whole number section. Right now, our whole number section only has 0 there, but we need to move one of the recurring decimals to join the whole number section. So ideally, remember the place value of that recurring decimal, you are just moving one of them. So moving one of them, it means you are just shifting the first digit over there to join the whole number section. And shifting it, just the first digit, you have to multiply through by 10. Again, we've generated an equation. The next step is to move one of the digits, which is recurring, to join the whole number section. And in moving just one of it, you multiply through by 10. So we say equation 1 by 10. Equation 1 by 10. So when we multiply equation 1 by 10, this is equation 1. X equal to 0.1 recurring. What are we going to obtain when we multiply through by 10? Can you guess?
1.1.
Oh, it's an equation. So every multiplying through by 10, it affects the left hand side and also affects the right hand side. So what are we going to obtain?
10x is equal to 1.1.
So
10x
10x
is equal to 1.1.
is equal to 1.1 recurring. Do you understand why I've written 1.1 recurring?
Yes, please.
Good.
Yes, please.
No, please.
All right. So the one who understands why I've written 1.1 recurring, can you explain why I've done so? Anyone?
Because you just
Anybody can answer, please. Go ahead. Perhaps
because
uh,
you just added one decimal place to the number, so which means there's more of them coming.
okay. So our dear sister who wasn't getting why I wrote 1.1 recurring. Have you understood why? Okay. So as we said, the main reason why we had 1.1 recurring is for the fact that I have just shifted one of the recurring value to join the whole number section, and I still have more of the recurring number after the decimal point. That's why I still have 1.1 recurring. Okay, so that has given me another equation, which is equation number 2. Now, if you look at equation 1 and equation 2 carefully, you realize that there's something unique, which is going to make it easy for me to do away with the recurring values. Equation 1 has 0.1 recurring. Equation 2 has 1.1 recurring. So at this point, I can get rid of the recurring value. I can get rid of the recurring values. And the best way of doing that is to simply subtract. So it will be equation 2 minus equation 1. So equation 2 minus equation 1, it's going to be 10x minus x, which will give me 9x. And then 1.1 recurring minus 0.1 recurring. What answer will be left?
1.0.
It will be left with 1.0, or in the same way, it will be left with 1. So at this moment, we are looking for the value of x. So we divide both sides by 9, and hence x will be equal to 1.1 divided by 9. So this is our answer to the question. Can you check from your calculator, please? Just pick your calculator and check. 1 divided by 9 and send it to decimals. What answer are you getting?
0.1 recurring.
All right. Please, this is just the beginning. What I've just done, does it make sense?
Yes, please.
Okay. Can we take another example?
Yes, please.
All right. So let's, question number 1 is the same as question number 2, just that there's a slight difference. The slight difference is that question number 2 is having a whole number and then a recurring decimal, unlike the first one. So let's consider question number 2. So we are looking at converting 1.2 recurring to a fraction, let's say in the form a on b. So what is the first step did I say you should consider? What must you do?
To create an equation.
Consider an equation.
You create an equation. So we can say that let our question be equated to a variable. Let's call the variable x. So x equal to 1.2 recurring. Then in this case, we said that if you have only one digit after the decimal point recurring, then you must transpose one of the digits which is recurring to join the whole number section. You are just transposing only one of them. So since we've generated equation, we can call it equation 1. So transposing only one of the digits to join the whole number section, then you must multiply through by what number?
2.
What must you multiply through by?
10.
10. Good.
10.
Because the place value is just tenths. So we have equation 1 multiplied through by 10. And when we do so, it means x is going to be multiplied through by 10, and that will give me 10x. 1.2 recurring. When you multiply it by 10, what are you going to obtain, please?
12.2 recurring.
12.2 recurring. That is wonderful. That is wonderful. At this moment, we have generated equation number 2. Our main concern right now is to get rid of the recurring decimals. And we've succeeded writing 2 equations which can help us do away with the recurring decimal. So what can we do to do away with the recurring decimal from equation 1 and 2? What must we do?
You divide both sides by the coefficient of x.
Are you sure that we divide at this moment?
You subtract equation 1 from equation 2.
Yes, we subtract both equations. So equation 2 minus equation 1. That will be giving us 10x minus x, which is an answer of what?
9x.
9x. Here is 12.2 recurring minus 1.2 recurring. What are we getting? 11. or 11.0,
Yes.
by just 11. Any question on that before I move on?
Nope.
Good. So at this moment, to get our value of x in a fraction form, what must we do?
You divide both sides by the coefficient of x.
Very good. So we divide both sides by the coefficient of x, which is 9. So we end up getting x equal to 11 on 9. Can you confirm it on your calculator, please, that 11 on 9 is the same as 1.2 recurring?
1.2 recurring.
I hope it makes sense.
Yes. Yes.
Yes, please.
All right, I'm pausing for any question. Please, do we all understand how to write recurring decimal to fraction in terms of when only one recurring value is after the decimal point? Do we all understand that?
Please, yes.
Yes, sir.
Good. Okay, so if this is understood, then we are moving on to the next level. This time around, we are having 2 digits after the decimal point recurring. So 2 digits after the decimal point recurring. Example may be, so examples of 2 digits recurring, we may have 3.12 recurring on top of the 1 and the 2. Another may be 0.34 recurring on top of the 3 and then the 4. And you may have others going on and on and on and on. As I said, right now we are looking at when you have recurring decimal right after the decimal point. So I'm going to take these 2 examples and then we use it to understand the whole concept of how to convert recurring decimals to fractions when you have 2 digits recurring right after the decimal point. Now you should understand that what I have here means 3.121212. Likewise, and it goes to infinity. What I have here means 0.343434, and it goes all the way to infinity. So there are a lot of 3/4s. There are a lot of 1/2s all the way to infinity. But how do we change these to fractions? So the same procedure as we did for the first, we said generate an equation for your question. So we can say that let a variable a equal to the recurring decimal 3.12. Then you label it equation number 1. Now, the process is, our major concern is to get rid of the recurring decimal 1, 2. So what must we do? We need to transpose some of the recurring decimal to join the whole number section. You transpose some of the recurring decimal to join the whole number section. Remember, right after the decimal point, you have the recurring decimal 1 and 2. So we need to transpose both the 1 and then the 2 at the same time. So if I may ask, how can we transpose 1 and 2, which are the recurring decimals, from this question to join the whole number section? We need to multiply through by a multiple of 10. By which multiple of 10 should it be?
100.
100. Wonderful. So we can say that equation 1 times 100. The reason for we multiplying through by 100 is to transpose the 1 and then the 2 at the same time. That's why we are multiplying through by 100. So this is going to lead us to 100a is equal to, yes, what else are we getting here?
312.12.
0.12. Wonderful. Is it just 0.12?
Recurring. Both
Recurring. Recurring on top of the 1 and then the 2. That has given us equation number 2.
No, please, recurring.
All right. So at this moment, you realize that from equation 1 and equation 2, we have recurring right after the decimal point. So we can actually get rid of the recurring values by simply subtraction or subtracting. So that is going to be equation 2 minus equation 1. So 100A minus A will give us what answer, please?
99A.
99A equal to 312.12 recurring minus 3.12 recurring. What are we left with? 309. Wonderful. So at this point, we want the value of A, and that will give us a fraction that we desire. So we divide both sides by 99, divide here also by 99. So we have A equal to 309 divided by 99, which is the answer to the question in Can you confirm it, please?
Yes.
So I
Confirm to.
all right. So that is it. You can actually go ahead and write it in a mixed number form. But remember, I told you that we are leaving the answer in the form A on B. So that is why I'm just writing it as that. Either than that, I could have gone ahead to write it in a mixed number form. Please, does it make sense?
Yes, please.
All right.
Yes, sir.
Let us do the next one, just to echo whatever I've just done here. So the next one, please, are we all following?
Yes, please.
Yes, sir.
Wonderful. Wonderful. So we can say that let a variable x equal to the question 0.34 recurring on top of the 3 and then the 4. Then we label it as equation number 1. Remember, 2 of the digits are recurring right after the decimal point. So it means we need to move both of them at the same time. So since we are moving the 2 digits at the same time, then we need to multiply through by 100. So we can say equation 1 by 100. And that is going to lead us to 100 of x should be equal to 34.34 recurring. Because we just moved 2 of the digits which are recurring to join the whole number section. So this is what we are getting. That is giving us equation 2. Please, do you all understand that?
Yes, please.
All right.
Yes.
Then we can say we've gotten to a
Yes,
stage
please.
whereby we can easily get rid of the recurring values by simply subtracting. So equation 2 minus equation 1. And that will give us 100x minus x. That will give us 99x. And then 34.34 recurring minus 0.34 recurring. It will still lead us to 34 exactly. Then we divide both sides by 99. Divide both sides by 99. And x will be equal to 34 on 99. Please, can you confirm it from your calculator? Can you
0.34 recurring.
Very good. So that is it. Okay. So the same thing is done, like it keeps on going when you are dealing with recurring of 3 digits. Of 3 digits. Yes. So right after the decimal point, you have 3 digits recurring. In this case, what must you multiply through by if there are 3 digits recurring?
1,000.
You must multiply through by 1,000. And then you keep on manipulating and manipulating until you get your final answer. Are we all clear?
Yes, please.
Okay.
Yes.
Now, okay, kindly ask your question before I launch into the deep.
Sir, please, what do you mean the recurring dot is on the last 2 numbers in the decimal point? Doesn't
Very
that
good. I- If I got you right, you mean in this sense you are having some digits recurring and others not recurring, right?
yes, please?
Good. That is what I'm launching into. That's what I'm going to talk about. So I wouldn't answer you, but I believe when I go through that with you, we have some few minutes. So if I do that with you, you understand the procedure. So as I said, we've considered how to write recurring decimals which begin right after the decimal point. Now we are moving on to how to write recurring decimals to fractions when some digits after the decimal points are not recurring and others are recurring. That's what we are going to consider now. So I have this question with you, but let me introduce a page. Hold on just a second. That's the assignment you'll be doing for me today. So I'm adding more assignments. So you have to make sure that you do the others. Good. So as I said, we are looking at when you have some recurring decimals whereby part of it is not recurring, others are recurring. Example may be, we may have 0.1, then the 2 is the only digit recurring. You may have 3.45, it's only the 5 which is recurring. The 4 is not recurring. You may even have 0.312. The 1 and then the 2 are recurring. The 3 is not recurring. And then it goes on and on and on and on. Can you give me another example? Just give me a question whereby some digits are recurring, others are not recurring right after the decimal point. Yes, who is bringing a question? 0.65.
5.
And the recurring is where?
5.
On the 5. Okay. So there are lots. I may even have a whole, yes?
1.163 and the 1 and the 6 and the 1 and the 3 are recurring. 1.163.
And then the 1?
The 1 and the 3 are recurring.
Okay. Now, from what you've given to me over here, it means the 1, 6, and 3 are all recurring. I remember telling you that when you put it on top of the first and last, it means all the 3 are recurring. Or whatever is in the middle is still also recurring. So that one is slightly different from the first 4 examples. Okay, so let us do that before the time is up. So this is the procedure you need to consider when you are dealing with writing recurring decimals for which some digits after the decimal point are not recurring and others are recurring. I'm going to consider question 1. Let me call it number 1 here. This is number 2, and that will be number 3. I'll consider number 1 and number 3. Number 1 and number 3. Because number 2, if you follow number 1 carefully, you can do number 2. Can I move on, please?
Yes, sir.
Yes.
You must generate an equation. So you can say that let a variable, let's say x, equal to the question. So you have 0.12 recurring on top of the 2. So you label it as equation 1. That's the first step. The next step is, this time around, you must transpose the digits which are not recurring first to join the whole number section. The digits which is not recurring, you must transpose that digits to join the whole number section first. That's the first thing you need to do. Now, how many digits are not recurring after the decimal point in this question?
1.
1. So in this case, if we have to transpose the 1, then what must we multiply through by? What power of 10 should we multiply through by?
10.
10. So equation 1 by 10. That's what you need to do. So you are going to obtain 10x equal to, what are we going to be left with on this side?
recurring.
12.
1.2 recurring. It is 1.2 recurring. So we label it equation number 2. Then after succeeding transposing the digit which is not recurring, then now you can consider transposing one of the recurring decimals. So in this case, we have only one digit which is recurring at this moment. Hence, how can we transpose one of them to join the whole number section?
By 10.
We multiply through by 10. So that is going to give us equation 2 by 10. And that will be leading us to equation 2 is what we have here. So multiplying through by 10, we are going to get 10x times 10, which will give us 100x
10.
equal to then 1.2 recurring. Multiply through by 10, what do we have?
12.2.
12.2 recurring.
2 recurring.
That's equation number 3. So you realize that at this point, we can easily do away with the recurring decimals. And that will be done away from which equations?
Equation 3 and equation 2.
Very good. So then we can say equation 3 minus equation 2. Equation 3 minus equation 2. What are we obtaining from there? 100x minus 10x will give us an answer of what?
90x.
90x equal to 12.2 recurring minus 1.2 recurring. What will be left? 11. So we divide both sides by 90, and hence we'll end up getting x equal to 11 on 90. Can you confirm from your calculator that 11 on 90 is giving us 0.12 recurring?
Yes, please.
Please, any confusion over here? Do you have any question on what I've just done?
Please, sometimes can you just decide to end it at 100 and it will still work? Or you'll not get the mark?
Can you come again? Do you want to tell me
Please,
that?
if,
Yes.
for example, I ended it at 10 and I got the answer, does it mean there would be no need to continue? Or I would get it wrong for method?
You ended, so let's say we have various lines. We have line 1,
Yes.
line 2, line 3, line 4, and then final line is line 5. So you ended at which line?
Line 2.
Line 2. If you end
Yes,
at
but I
line
was still
2, you've still not answered the question. So it means that you wouldn't get your answer right. You'll be marked wrong.
okay. Thank you.
All right. Any other question, please? Okay, can we try question number 3 together?
Yes.
All right, we are looking at question 3. I'm using a different color for this time. So looking at question 3, we generate an equation. So we can say that let a variable x equal to 0.312 recurring on top of the 1 and then the 2. Then we label it as equation 1. Then what is the next step? What did I say you should do?
Please remove the 3 to add the whole number.
Okay, so you have to transpose the 3 to join the whole number. That's the next step. So in this case, since the 3 is the only digit we are transposing to join the whole number, what do we need to multiply through that can help us move the 3?
10.
So we multiply through by 10. So equation 1 by 10. And that will give us 10x is equal to 3.12 recurring on top of the 1 and then the 2. Please, do you all understand up to this stage? That's equation number 2.
Yes, please.
Yes, please.
Then what is the next step from
Yes.
what's the next step from equation 2?
We multiply by 100.
Why do we need to multiply through by 100?
Because there are two numbers recurring.
Okay, so you need to multiply through by 100 to move some of the recurring decimals to join the whole number section this time around. And we have only two digits recurring at this point, which is the 1 and then the 2. That's why we need to multiply through by 100. So equation number 2 by 100. So this time two digits are recurring. That's why we are multiplying through by 2 to move the two digits which are recurring. That's why we are multiplying through by 100. Please take note. So that will be giving us 100 by 10x. That will give us 1000x equal to 100 by 3.12 recurring. That will give us 312.12 recurring. And that is giving us equation number 3. Please, does it make sense?
Yes, please.
Yes, please.
Can I move forward?
Yes, please.
At this point, you realize that between equation 3 and equation 2, they have something in common we want to get rid of, and that is the 0.12 recurring. So we simply need to subtract. So equation 3 minus equation 2. And that will be giving us, did I write 100? It's supposed to be 1000x.
1000.
Yeah. So 1000x minus 10x, that will give us 990x equal to 3.312.12 recurring minus 3.12 recurring. What answer are we left with?
309.
309.
309.
So we divide both sides by 990, and that will be giving us x equal to 309 divided by 990 as our final answer. Can you check from your calculator? Please, are we all clear?
Yes,
Yes,
please.
please.
Yes, please.
All right. It's unfortunate our time is up, but I'm very happy I've been able to go through the steps with you. And I believe strongly that you do all understand whatever I've explained at this moment. You need to practice. You really need to practice before you can grasp it at your fingertips. You need to really practice. So I have these questions for you to try your hands on. I'd like you to do them and then give me a feedback. The first part of the question is all about terminating decimals being changed to rational numbers. And then the second part of the question is non-terminating but recurring decimals that needs to be changed to rational number form. I believe you can do it. Do that and give me a feedback. Thanks so much for joining the call. I'm privileged to be your facilitator today. Have a lovely day. Bye-bye.
Bye.
Bye.
Bye. Bye.